Hello students, welcome to AMU tutorial. This is the fourth lecture of course Hydraulics, and today we will be discussing about the Pascal's law. Before going into the details of Pascal's law, let us discuss about the fluid pressure in a static fluid. Suppose we have considered a wedge of a fluid which is having delta x length in x direction, delta y length in not delta y, say delta z in z direction, and delta s will be the hypotenuse. Okay, and the width b is into the plane like this. So this will be the wedge. This will be the wedge. Okay. Now suppose that the two-dimensional view of this wedge is here. Okay. So now suppose the upward vertical pressure is say Pz, which is acting over here in upward direction, and the horizontal pressure Px is acting in this direction. Okay, positive direction. And suppose the normal pressure is normal to this surface. Okay, so normal to this surface, normal pressure, say this is Pn. Okay, which is inclined at an angle theta with the vertical, and the inclination of this wedge is also theta, is also theta. Okay, so if we will resolve this into two components, this will be Pn cos theta and this will be Pn sin theta. Okay, P. Okay, and suppose the weight of this wedge is say dw, small wedge, a small for a very small volume. Okay, so the weight will be, how to calculate the weight? The weight will be the specific weight of this wedge, weight of wedge will be equal to specific weight or unit weight multiplied by volume. Okay, if you don't know the meaning of specific weight, you should watch my lecture on properties of fluid. The suggestion, it is suggested over here. You should watch this lecture first. This is the properties of fluid. It is the very basic of this subject hydraulics. So first watch this lecture. Okay, first watch this lecture, then you will be very well clear about the specific weight or unit weight. Okay, so specific weight or unit weight multiplied by the volume. Now what is the volume? Volume can be calculated by calculating the area of this triangular wedge multiplied by the whole width, which is b, whole width. In this way you can calculate the volume of this whole wedge. Okay, and this volume multiplied by the unit weight will give you the weight of the wedge downward. So now let us calculate the weight, that is W. Now volume will be, specific weight is given as gamma, multiplied by the volume will be area of this triangle, half into delta x into delta z. Okay, this will be the area multiplied by the width. Okay, now further we know that gamma is equal to rho times g. Now what is rho? Again you have to watch the previous lecture, okay, then you will know about this. So rho times g multiplied by half into b into delta x into delta z. Okay. So this will be the weight. Okay, this will be acting downward. Now in order to this wedge to be in an static equilibrium, there must be some conditions. For it to be in equilibrium, summation of all the forces along x should be equal to 0, and summation of all the forces in z direction should be equal to 0. If these two conditions are satisfied, then this wedge will be in a state of static equilibrium. Okay, so in this condition the fluid is considered to be at rest, and this is the static condition of fluid. Okay, this is the static condition of fluid. So now summation of fx means sum of all the forces acting along x direction. Okay, so here if you look here, this is the pressure which is acting in this direction. Okay, so in order to calculate the area force, how you can calculate? The pressure is equal to force multiplied by area. Okay, you can watch the concept of pressure in my previous lecture on properties of fluid. Okay, I have discussed it, and I have also discussed the units and dimensions of all these physical quantities in my another lecture, which is dimension units. So you should watch it first. Okay, it is coming in the suggestion here, over here. Okay, so you should watch it. Okay. So now pressure is given. When we multiplied this pressure with the area, with the projected area, the pressure here, it is px. Okay, and the area will be delta z times b. So px multiplied by b delta z, this will be the force which is acting in this direction. This will be the force. So force will be px times b times delta z. Okay, this will be the force. Pn, now Pn is the normal pressure which is acting over this surface. Okay, so the force will be B delta S, and since the horizontal component is Pn sine theta, so the horizontal component of this force will be Pnb delta S sine theta, and this should be equal to 0. Here we can say that Px delta x minus Pnb delta S sine theta is equal to 0. Let us say this is 1. Okay. Another condition is summation of all the forces in z direction. So now let us consider summation of all the forces in z direction. So Pz is the pressure which is acting upward over here. So force will be Pz into delta x into b. Okay, this will be the force. So Pz b times delta x. This is delta z. So okay, there is minor correction. This is actually delta z. Okay, this is actually delta z, not x. Okay. So let us say the upward force is Pz b times delta x, and here you can see that the downward component is Pn cos theta, so it will be minus Pn. B delta S will be the force and the component will be cos theta, so this will be the downward. Another downward force is weight, so weight we have already calculated. Okay, so it is half times rho g times B delta X delta Z, and this whole summation will be equal to 0. So we can simplify here. If you will simplify, you can find out B common in all the terms. So this will be Pz delta X minus Pn delta S cos theta minus half rho g delta X delta Z equal to 0. Okay, we have got another equation, that is equation number 2. Now let us consider another condition. Okay, another condition, and that is say, okay, now we also know that delta x can also be written as delta S cos theta, and delta Z can also be written as delta S sin theta. Okay, we can write both delta X and delta Z in terms of delta S like this. So we can put both of these values in our two equations, equation number 1 and 2, and let's see what we will get. Okay, first let me clear all this. Okay, let me clear all this. Okay, here we go. So now put this in equation 1, so it is Px, and if we put in terms of delta S, we will get delta S sin theta, okay, minus Pn, okay, and B is cancelled over here, so okay, I forgot, okay, this one, so it is Pn delta S sin theta equal to 0. So you can very well see that these two terms are equal, so it means that Px is also equal to Pn. This is very important conclusion of this equation. Okay, I will explain this in later on. Okay, now put both these two in equation number 2, so let's see what we will get. Okay, let me clear all this. Okay, first let me clear all this. Okay, now see, Pz delta S cos theta minus Pn delta S cos theta minus half rho g delta S cos theta times delta Z. I'm not changing delta Z. Okay, I'm not changing this one because this is the depth and we need this term. Okay, so let us not change this one. Okay, just change the delta X terms. So here also you can see delta S cos theta, delta S cos theta, delta S cos theta is common in all the terms. So on simplification we will get Pz minus Pn minus half rho g delta Z equal to 0, and further on further simplification we will get Pz is equal to Pn plus half rho g times delta Z. This is another very important conclusion. And but what does it mean? Okay, if you see this conclusion, it means that the pressure in horizontal direction is equal to the normal pressure. What does it mean? It means that there is no change in pressure in horizontal direction. Okay, so in a static fluid, the pressure does not change in horizontal direction. This is very important. Okay, in horizontal direction there is no change because px remains same as to the normal pressure. Whatever will be the normal pressure, the same will be the uh, horizontal pressure. Okay, so it does not change in x direction, but in y direction, due to this weight, this is the weight component. Okay, this is the weight component. So due to weight, what will happen, that the pressure changes along the depth. Okay, the pressure changes along the depth. Okay, so this is another conclusion, that the pressure, there is a change in pressure, there is a pressure gradient in the vertical direction, okay. So these two are very important conclusion of this uh, video. Okay, now let us say that, okay, I have discussed this one. Okay, uh, there's no pressure change in the horizontal direction, and the vertical change in pressure is proportional to the, yes, this is proportional to, you can see here, the vertical change in pressure is proportional to the depth, is proportional to gravity, and is proportional to the density of fluid. Okay, this change is proportional to all these three terms. So we can conclude here. Okay, so vertical change in pressure is proportional to density, is proportional to gravity, is proportional to depth. Okay, so this is the pressure in a static fluid. Okay, remember the condition is static fluid because we have considered the static equilibrium, that is fx equal to 0 and fz equal to 0. Okay, okay, we have not considered the third term, but if we have considered another dimension, then should be also equal to 0, but it's not 3D, it's 2. We have discussed the 2D example, so let us say these two conditions. Okay, now come to the Pascal's law. Now in the previous example, we have studied that Px is equal to Pn. Okay. And Pz is equal to Pn plus half rho g times delta z. These two were the conclusion that we have derived from our previous example, okay, our previous illustration. But now, if suppose we have that the wedge was like this. Okay, the wedge is like this. Okay, this is delta z and this is theta. If say theta is very small, if say theta is 0, theta 0 means this delta z will become 0, this delta z will become 0, and this wedge will reduce to a point, okay. So what does it mean? It means that if we put delta z 0 here, so it will give us px equals to pz equals to pn, and this whole equals to say p. Okay, what does it mean? It means that pressure in horizontal, in vertical, and normal pressure all are same, where at a point within a fluid. Okay, interesting. So if suppose this theta, this theta is very small, is say 0, okay, is very small, say 0, then delta z will be 0, and if we put delta z 0, then this will reduce to pz equal to pn, and also pn is equal to px. So all these three components are equal, and delta z 0 means this will be 0 and there is no theta, so this will be a point, this will be a point. So pressure will be same, it means pressure is same. So this give us a very important law, that is the pressure at a point. Okay, the pressure at a point in a fluid, the fluid must be same. Okay, the fluid must be same, and it should be at rest in a static fluid. Rest means in a static fluid. So the pressure at a point in a fluid at rest is same in all the directions. Okay, is same in all the direction. We can see here the normal pressure is equal to px and pz. Okay, so it's same in all the directions. This is the Pascal law. Okay, this is the Pascal law. So it means that delta p over delta z is equal to gamma. Okay, the pressure gradient in the z direction is equal to gamma. It's constant actually. Okay, so we can also say that p1 minus p2 over z1 minus z2 equal to minus gamma. This will give us p1 minus p2 equals to gamma times, what is gamma? It is a specific weight. Okay, specific weight. So z1 minus, or you can say z2 minus z1, because this is the minus sign, so multiply this minus here, it will give you z2 minus z1, and we get here p1 is equal to, or you can say p1 plus gamma z1 equals to p2 plus gamma z2, which will be equal to some constant. This is the conclusion of Pascal. Okay, this is the conclusion of Pascal. Okay. Now, after discussing Pascal law, we have how to calculate a pressure. We calculate pressure in terms of absolute pressure and also uh, in terms of gauge pressure. Okay, we denote pressure in two different terms. Okay, so absolute pressure and gauge pressure. So absolute pressure is measured above the absolute zero. It means that the absolute pressure is always positive. It is never negative. It is always positive. Okay. And how to denote this? Absolute pressure is always denoted by writing ABS or absolute in the subscript. Okay. So it is always above absolute zero, means always above the absolute zero pressure. So it will be P atmospheric plus gamma times H. This is the absolute pressure. Okay. Suppose we are calculating the absolute pressure at this point Pm. So it is the reference, say P atmospheric pressure, and at here up to here the pressure will be gamma times H. So P atmospheric pressure plus gamma times H will give you the pressure at this point P. Okay, absolute pressure. Okay, how to measure this? Absolute pressure is measured by aneroid barometer. Okay, or mercury barometer. Okay, aneroid barometer or mercury barometer. So this is the absolute pressure. Another way to denote pressure is gauge pressure. Gauge pressure is pressure at say M minus absolute pressure. It is a difference, will be equal to gamma H. This is the gauge pressure. This is the gauge pressure. This is a gauge pressure. Okay. It is always measured with respect to the atmospheric pressure. Okay. Sorry, I have written absolute here. It is not absolute, but it is atmospheric. Okay, it is atmospheric. Now, since the pressure can be above atmospheric pressure or below atmospheric pressure, so the difference could be positive or negative. So it means that the gauge pressure can be positive or negative. Negative gauge pressures are called vacuum pressure. Okay, we measure the gauge pressure by manometers or Bourdon gauge. Okay. So this was all about the pressure in a static fluid. We have learned today about the pressure in a static fluid, about the Pascal's law, and also we have discussed a very brief in a brief moment about the absolute pressure and about the gauge pressure. If you have any question regarding today's lecture, so you can very well post your questions, okay, in the comment box, because if you post your question in comment box, then only I will be able to answer it quickly. Okay, and your question, the answer to your question may be helpful for the others also. Okay, so post your questions, and if you have uh, any more uh, uh, any more concept to learn, then you have to log into this website. Okay, and you have to download the course material. Okay, download course material. Okay, download course material. In this way you will be able to get the concepts very clearly. Okay, and also you have to download the slideshow that I have also given you the link over here on this website. Okay, so go and check. Okay, so that's all for now. Okay, goodbye.